Right class, this is a video just clearing up some misconceptions on the forces and Newton's chapter. And these are some exam questions. So a particle of mass 6 kg is initially at rest. So here it is and it's at rest. I'm saying 6g going down because that's what we normally do. And it's acted upon by a force R at AI plus 10j. So remember that's a vector. So that's the AI and 10j. Now why I know it's going in this way? Because it says it's acting on a bearing of 300. Okay? So to be clear, that's your 300 degrees here from north, and that's your force R. Let's go to pen, and that's your R. Find the exact value of A. Well, with this whole thing here is 300, up to here is 270, right? Because that's 90, 180, 270. So you can use this as 30 degrees, or from here to here as 60. Imagine that's 10j, so on this side here is 10j as well. So you just get a triangle like so. I'm going to use 30, but it will still work with 60. So that's 30. We have A, I, we don't know, that's, and going upwards is your 10j. So we can assume it's 10j on this side. So what do we start with? We know tan theta equals opposite over adjacent, right? So the adjacent is A and the opposite is 10j. So we just do tan theta equals 10 over A, and that's 30. So, you know, so A will equal 10 over tan 30, and you'll get the answer 10 root 3. So doing this is your method mark. That's a method mark. Now look at the context of A's. Which way is A going? A is going this way. Now this way, like on the graph, is positive x. That's positive. If it's going this way, it must be what? Negative. So actually the answer to A is minus 10 over root 3, and many of you are missing out that key mark there. B. Right, lots of you know how to find the magnitude. That was really good. Do write R equals magnitude, just say magnitude. So the magnitude is what this is, okay? So it's like Pythagoras theorem. So it's the square root of 10 squared plus minus 10 root 3 squared, what A is. Now most of you did that but got the wrong values for A, so you know it was difficult to get marks there. And then you'll find out that R equals 20 newtons. Quite easily done. C. Work out the magnitude of the particle. Work out the magnitude of the acceleration of the particle. Right. Always states F equals ma. What forces do we have? Well, can we see the main force? I'll draw it on this diagram here. That's 20. R equals 20, right? R equals 20. So that means you've got your 20 equals, what's the mass of the object? 6 times your A. So A must equal 10 over 3 meters per second. You need to write that because it's acceleration, right? So that's your M1 and your answer 1. Find the time it takes for the particle to travel a distance of 640. So we knew that. So D S equals UT plus a half AT squared. Now why we use that is we know S equals 640. We have A equals 10 over 3. We know it's initially at rest, so U equals 0. And we need T, right? And that's why we use this SUVAT formula, because it has U, T, S and A. Substitute those values in, and you should find, once you resolve it, so what we do is 640 equals 0 times T. 0T plus a half times 10 over 3 T squared, and then we get T equals 8 root 6, which is 19.6 seconds. Okay, that's a quite straightforward M1 answer, accuracy 1 mark, that we should all be able to get as well. Now can you see it all falls down, this question, if we mess up this part here, because we can't do the rest of it. So hopefully that helps you. Okay, so this question caused a lot of confusion for some people, but once I break it down, all will become clear. Now, questions like this, the understanding of it is all essential skills to do well in mechanics. Now, you've got a car of mass 1,200 kg, pulls a trailer mass 400 kg along a horizontal road. The car and trailer connected by a tow rope modelled as a light inextensible rod. Now let's break this up in each stage. Okay, here's my car. And there's the tow rope here, attached to the trailer. Right, let's add. The car is 1,200 G. The trailer is 400 G. The engine of the car provides a constant driving force of 3,200 newtons. That's a key point. So let's assume 3,200 must be going this way. Okay, that's newtons. The horizontal resistances of the car and trailer are proportional to their respective masses. So proportion, if you remember GCSE of inverse and direct proportion, we normally call K a constant of proportion, and that's what people missed out. So there's a resistance force which is proportional to their respective masses. Well, their respective masses are 400 G and 1,200, right? So that must be 1,600 K, as in that's a constant proportion there. And that's acting the other way. Now the car acceleration is 0.4 meters per second to minus 2, A. Find the resistance and motion on the trailer. So we're trying to find out what this is, right? How much is going this way? So if you state or imply somewhere this, that is worth a method mark. Alright, let's continue this question. So remember, F equals MA. What have we got going? We've got 3,200 going this way minus 1,600. So the total force is 3,200 minus 1,600 K. And that's got to equal the mass, or the total mass is 1,600 times 0.4, because that's the acceleration, that's A, and that's the mass. And that's your F force. Now rearrange this to solve K, which I know you can do yourself, and you'll get K equals 1.6. Now find the resistance of motion on the trailer. So K is combined for both, but the trailer's 400. So the resistance force of the trailer has got to be 400 times the 1.6, which is 640 newtons. Now this one is a little tricky. We're trying to find a tension in the tow rope, which is, this is the tow rope, and if the car is going this way, the tension is going to act in the opposite way, okay? That should make sense to you now. So that's your tension. Now, earlier we know K is 1.6, right? So the resistance forces, because we're focusing on this bit here of the car, is going to be 1.6 times 1200, and that is 1920 newtons. That's going this way as well, and we have this as 400. Okay, G. Okay, and I just do this out of habit, but we're all talking about horizontal forces, so we don't need to use G. Okay, so what forces have we got going around essentially this system right here? So we're going to get the total forces is the 3200, because that's going this way, minus the 1920 of the car, and minus the tension. And that's going to equal, because we're using the car as a system, let's use the mass of the car. So that's 1200, G is gravity, times A, which is times 0.4. And if you resolving that, then T will equal 800 newtons. Now, there's another way to look at it, and you can look at it in the context of the trailer. So the trailer is 400 times 1.6, so you've got 640 here newtons. Okay, so if you look at the context of the trailer, you would have tension, and we're looking at the trailer from the other perspective. We treat tension as the opposite way, and you can also write tension minus 640 this time, because we're using a trailer as the model. So imagine if you're saying there's a resistant force going 640, then the tension here is going to act the other way. So you're going to have T minus 640 is going to equal 400. That's the weight of the trailer times 0.4, and you would still get, and you have to start using the trailer instead. T equals 800. Now why do we take T as positive? Because the car is moving this way, so that should be the positive direction. And that can be a little bit challenging to understand, but I hope that gives you some understanding. Okay, let's have a read of this. When the car and trailer travel at 25 meters per second, the tow rope breaks. Assuming that the resistances to motion remains unchanged, find the distance the travel travels before coming to a stop. So this will kind of make sense. So obviously the trailer's on its own. The rope here has broken, but if you're pulling at a force and you let go on a toy with a string, this will continue going forward. And it's asking you, well, how far, the distance, or S, it will travel after it breaks. So let's assume the resistances of motion are unchanged, so that is still 640 newtons from before. Now, we're still using F equals ma, so we get F here would be, the forces here will be minus 640. I'm going to write that now. Now the mass of the trailer, because we're only talking about the trailer, is 400. Right, kg or g, okay? But we just use the 400 because we're not going to use gravity here, because we're talking about horizontal motion. So that's 400A. Now you would find A equals minus 1.6 meters per second, because that will make sense. It's traveling this way, and so probably at 25 meters per second, but it's going to slow down, and it's going to decelerate, so it eventually stops. Now what do we have? Okay, we have u, because that's the start before it breaks, that's 25. We have v, because we want to know when it comes to a stop, so v equals 0. That's when it stops. A, we have minus 1.6, and we're trying to find S. So what formula in SUVAT has all of that? Well, it's got to be the v squared equals u squared plus 2as. So substitute your values in. 0 equals 25 squared plus 2 times minus 1.6 s, as in the letter S. Don't get confused for the 5. Solve for S, so S equals 195 meters to 3 significant figures. And that's your answer. Method mark here, answer mark here, and your method mark for this point up here. So these are all skills that you can use. Now 4D, state how you can use a modelling assumption that the tow rope is inextensible. And I'm just going to show you the answer for this. So to explain this, the acceleration of the car will be equal to acceleration of the trailer, because this is moving as sort of one body connected, because it's inextensible. So it'd be like moving as one body. So the car and trailer will move as one, and that's the answer they're looking for. Okay, let's explain this question in detail, because these skills do become relevant in year 2, and you need these skills to answer mechanics exam level questions in year 13. Okay, that's A. We've got 0.8 here. The string passes through a smooth pulley, no friction. It's a rough horizontal table, so there's going to be a frictional force, okay, acting against the movement. Sphere B is here. Which hangs freely below the pulley. The magnitude of the frictional force between A and the table is Fn. So let's just call it F for now. Put a little n there. It's released from rest, and the string is taut, so it descends. So look, S equals 0.9, time T equals 0.8. One in A is B is particles, calculate the acceleration of B. So what do we need to do? We've got S T. Do we have initial speed at rest? U equals 0. So what can we use? We can use S equals UT plus a half AT squared, because it has all the information we need, and we're trying to find A is the question mark. So that's clear to use that. Correctly using that gets you a method mark. So substitute that all in. This is A, 0.9 equals 0t plus a half times A times 0.8 squared. That is it. So just solve to find A equals 45 over 16, and they will set rounded A equals 2.8125 or 2.8 meters per second minus 2. That's that. B, the tension in the string. Okay. So it depends where you're going to do the tension on. So let's do B. Okay, so if this is going down, this is clear, the tension must be acting this way. That's your tension. T. So we just need to look at this, and remember in year 2, really all we need to concentrate is a vertical motion, yes? Vertical motion. Don't overcomplicate things. So we're just looking at this system here, that's enough. So what do we start off with? B, F equals MA, right? So what's our forces here? We've got 1.2, and let's use this as a direction because that should be the positive direction, because you know the system is going down. So what's the force? You've got 1.2 G. Now we use G because we've got gravity acting on it. Minus T. Understanding this gets you a method mark. Equals, okay, that's our force. Equals mass times acceleration. Well done. Mass is 1.2 kilograms. What's the acceleration? We've worked it out in the prior question. Probably better to use just the fraction. So equals 1.2 times 45 over 16. And now you can solve that by working it out. And I'm not going to do that for you. So T is going to equal 1,677 over 200 newtons. And you can just write 8.385 or round it to 2 or 3 significant figures. I would say recommend 3, and that would be fine. And that is your answer mark. Now you can all do that, right? Right, part C. Use blue. It's saying the value of F. So we're working out this. We're using this system here. So imagine if friction, the resistant force is acting this way, tension is going to always act the other way. So that's going to help you know the direction. So that's the start. C. Now once you understand that, we're just looking at this system here. We can ignore everything down here now. So we've still got F equals MA. Always start with that. Write that down. So what's the forces have we got? Depending on which direction you use as positive, but it makes sense that if the block's going this way, that's your positive direction, right? So the force is going to be T minus F. Okay, that's the forces here. You can see that. Equals M, well the weight of that is 0.8. Right, we know if this is accelerating downwards at 0, what did we work it out as? 45 over 16. 45 over 16. That was A, right? Meters per second. And that's a smooth pulley, so there's no friction. So it's all acting like one body. So actually acceleration this way, this will go at the same acceleration. That should make sense. 45 over 16. So we just do 0.8 times 45 over 16. Now we have tension, because the tension on this rope is going to be the same because it's treated as one singular system. So however you want to do that, 8.385 minus F equals 0.8 times 45 over 16. Writing that actually gives you a method mark. Understanding this t minus f bit is a method mark. And just resolve and find f, and you'll get f equals 6.135, or anything close to that is acceptable, and that's your answer mark. Now D is what I would say a tricky one to solve. It says find the total distance travelled by A based on this information. Sphere B is 0.4 meters above the ground when it's released. Given that it does not reach the pulley, so that means A does not reach the pulley, and the frictional force remains constant throughout, find the total distance travelled by A. Now you would think that we can use S equals ut plus a half AT squared, okay, but that will give us this 0.9, which is the same from before. That doesn't include how, that means that this in this question, B travels 0.9, hits the ground, but there's still some force, or this A would still be moving along, and it will take time to slow down from this frictional force here. So for part D, we have to use V equals U plus AT, so that we know what speed A is travelling at once this hits the floor. So we know U is at 0, so we're going to get V equals 0 plus the acceleration at the start here, 45 over 16 times 0.8 seconds, because that's the time we know, 0.8. So what this gives us is that when, because it says it's 0.9 from the ground, 0.9, and that's what we kind of found out at the start, that hits the ground. And imagine in a real life context, if this hits the ground, this is still going to get pulled along a little bit, and the only thing that's stopping it from not reaching the pulley is this frictional force here. So we solve that to make V equals 9 over 4, which equals 2.25 meters per second. Now we can use F equals ma again. Now we can use this at A. So we've got minus F equals 0.8. That's the mass of A, because we're talking about this body. And we know that F, the frictional force, is what we have here. So then we get minus 6.135 equals 0.8A, and then A equals minus 7.66 meters per second. Okay, now this is a tricky question, because we know the initial U of this system is 0, right? That's at the start. But imagine when this B has hit the ground, this A would have moved the same distance to 0.9, and it's going to continue moving. And at this point, this is what we're working out. At this point here, it's still moving at what we found here, V equals 2.25. So in this new system, this is actually our U. Okay, equals 2.25. Because we want to find the total distance travelled by A. In fact, the final velocity, V, is actually has to be 0, because that's when it stops. Now that actually makes sense, but this question is actually really tricky, to be really fair. Our A is the same as before, what we've got here. and S is question mark. So this time we use v squared equals u squared plus 2as. Because we don't know the time here, it moves after 0.9. So we just substitute all that in for another method mark. So we get 0 equals 2.25 squared plus 2 times minus 7.66. S is our distance, and the solve to find S, and you get S equals 0.33 meters, and that's takes us up to 6 marks. Now remember, it's travelled 0.9 already, so S equals 0.33 add 0.9, which equals 1.23 meters, and that's the final answer. But this question is really tricky, so don't worry if you don't comprehend it fully, but you should be able to get the 5A, B and C correct.